yesterday was kind of a longer lesson. Today should be shorter because there's no new material here. We're just going to do some more examples of how we're working with these things. So that's basically all we're going through today are examples and a couple that you get to do as well. So again, just kind of reviewing, we always go from the point of intersection to the point on the circle. We set this up, two segments in the same line, always go together on the same side of the equation. So in number one here, our point of intersection is clearly right there. Okay, so point of intersection, point of the circle, that would be x, times the segment on the same line, which would be 3, equals 6 times same line 4. So there they are. There are 4 segments. There they are, all starting at the point of intersection and ending on the circle. And we do the math. 3x equals 24. So x equals 24 over 3, which is 8. All right. This one is the same idea for number 2, but you're going to have to use a little distributive property when you're doing it. Nothing too complicated, but don't forget to distribute. So start by setting up and take it from there. Same thing's taking place here, it's just that the point of intersection is moved outside the circle, and we have to resist the temptation I'm going to make these a little bit bigger for us here. We have to resist the temptation to do 5 times x equals 6 times 9. That's going to be wrong. It just doesn't work because x does not have a point, endpoint at the point of intersection. I'm going to do 5 times the whole thing, which is 5 plus x, equals 6 times the whole thing, which is 6 plus 9, but that is easy to calculate because they're both numbers, so that's 15. And then we just go ahead and we do our solution. So it's 25 plus 5x. 6 times 15 is 90, so subtract the 25 from each side. I get 5x equals 65. Divide by 5. That's 13. And we're all set. This one is a little more complicated. This one's going to definitely get into some algebra. And I have posted an algebra review video into the chapter 3 or chapter 10 folder. So make sure if you're struggling with factoring and foiling and that sort of thing, that you take a look at that algebra review video because it will be helpful for you if you're struggling with that. So let's set this up. Definitely more complicated. 3 times the whole thing, which is going to be x plus 2 plus 3. Equals, and we're going to simplify that in a minute, so don't worry, x plus 1, the external part, times the whole thing, which is x plus 1 plus x minus 1. Adding them together. Now, I can simplify this. That's 3 times x plus 2 plus 3 is x plus 5. Equals x plus 1 times, I'll take x plus 1 plus x minus 1 is 2x. Because the 1's cancel out, the plus 1 minus 1 cancels out. So that just becomes 2x for that length. Then I distribute. 3x plus 15 equals 2x squared plus 2x. Again, using distributive property here this way. This one I distribute that way. Because of an x squared equation, and I don't have x squareds on both sides that cancel out, I got to bring all the terms to one side. I'm going to bring them to the right side because the 2x squared is positive there. So I'm going to do minus 3x and minus 15. So 0 equals 2x squared minus 1x minus 15. Now we have to solve that. We can solve that by factoring or the quadratic formula. I'm pretty sure this one's going to factor. Now we have to use our AC method here. The AC method says I take the 2 times the negative 15, that's my product. Blank times blank has to equal negative 30. And my sum is still the middle term, so blank plus blank equals negative 1. And the numbers that make up that combination, we'll find out very quickly, are negative 6 and 5. So negative 6 and 5 are my magic numbers. Now, because there is a leading coefficient, a 2, I have to actually go back now and group that. So 2x squared, the negative 1x is going to be expressed as a minus 6x plus 5x, and the minus 15 equals 0. We group. Common factor here is 2x, leaving me x minus 3, plus 5, x minus 3 equals 0. These two things in the parentheses are exactly the same. They have to be. If they haven't, I've made a mistake. I then group those. I'm left with a 2x plus 5. And I get two solutions, either x equals 3 or x equals negative 5 halves. Now, the 3 solution works just fine for me because 3 plus 1 times 3 minus 1 is 4 times 2, that's fine. 3 plus 2 is 5, that's fine. If I do negative 5 halves, I'm going to come up with some negative lengths. So negative 5 halves is eliminated because that is a nonsense solution because it gives me negative lengths, which don't really help me very much. So my solution here is x equals 3. And that's a lot of algebra. But again, you're heading into Algebra 2 in the very near future. You have to get used to doing your foiling and factoring and that sort of thing again. That's why it's in here. All right, that was a tough one for today. The rest of these are a little bit simpler. I can make these a little bigger so you can see better. This one uses a tangent. So it's 1 times the whole thing, which is 4, equals x. And now when it's a tangent like that, remember, both are the same. So it's x times x. So x squared equals 4. So x equals positive or negative 2, but the negative 2 is a negative length. That doesn't make sense. So just x equals 2. For this one, it's 5 times the whole thing, 5 plus x, equals 7 times, oh gosh, it's a tangent, so it's times itself. So that's 25 plus 5x equals 49. So 5x equals 24, so x equals 24 fifths. Now you get to try number 7. Okay? 7's going to be tough. It's going to give you a quadratic that you're going to have to solve. So it's going to take some time. But just as a little hint, since it's a multiple choice type question here, you could just plug in x's and see which one works. So, little hint, you might want to give that a try. That's your question.